Okay, it's time to get started. Thank you, everyone, for joining our live lecture today. My name is Isaac, and I'll be the lead instructor for the lecture. And today's topic is going to be web security. Okay, so let's go ahead and let's dive right in. So, first thing we should talk about is your mindset as a developer in regards to web security. Okay, so you should always have the mindset that you're preparing for the worst and hoping for the best, because at the end of the day, you just really can't always check everything off. But you can do a lot to prepare for that. So let's just consider the amount of security needed for each software product you do. Okay, so for example, if you have a restaurant call you and they say, "Hey, we want a website with just a static menu," and that's it. It just shows all of our different menu options. Something like that probably wouldn't need a lot of security, right? We don't need any password encryption, no debit cards, nothing like that handled. So really, you don't need to go all out and incorporate all 9 yards when it comes to security for, say, something like that. Whereas on the other hand, if the same restaurant called you and they said, "We want a menu, but as well we want payment integration, and we also want advertising, and all this other stuff, user accounts," right? We're probably going to need to add a high level of security for something to that regard. Okay, so don't treat every project like it's the same in regards to the security measures that you incorporate, because it really is on an as project basis. Okay. So next, let's talk about your accountability as a developer. Okay, so as a developer, you're bound by certain laws when building software. So most of the time, if you're working for a company, right, the project manager, that they're all going to take care of this stuff and make sure that you're in line. But if maybe you're building freelance projects or something to that regard, you're going to need to make sure that you are compliant. Okay, so let's first talk about PCI compliance. Okay, so this is your personal credit card information. Okay, and this is very important for web developers because these days almost all applications have some sort of payment integration. Okay, and so to be compliant, basically the customer's credit card information can never hit your server. Okay, and that might sound weird, like, well, how do I build an app where that works? And typically these days, a lot of developers just use a third-party API, such as PayPal or Stripe, right? And they handle everything and it hits their servers instead. Okay, so if you are going to add payment integration to your software, make sure you read up on PCI compliance. Okay, so you can find that by going to PCIsecuritystandards.org. Okay, you can find all the official documentation here. Okay, next let's talk about HIPAA. So you probably already heard of HIPAA before web development, right? And so HIPAA applies the same as it does in other fields as it does in software, right? You have to be sensitive about the information you're handling in regards to people's health. So if you're building a project that involves transferring of healthcare data, then you'll definitely need to go to their government site here and read up on their cybersecurity standards, okay? So next, let's go ahead and let's talk about building security around actors. Okay, so oftentimes when you're building software, it's hard just to think, how can I prevent this from being used in a bad way, right? So instead of just taking that approach, think in terms of actors. Okay, so your users are going to be either good or bad actors. Okay, a good actor, someone who uses the site for its intended purpose, right? So a bad actor, however, would be someone who uses the site for their own purposes. Okay, so a good actor would be someone like a customer or seller, and bad actor would be maybe an internal employee that's hijacked some customer payment info, right? So think in those terms when you're building software, and it tends to help you, lay out your standards. Okay, next let's talk about trust boundaries. Okay, so these are different depending on what software groups you're working with, but they're pretty general in regards to the privileges that different areas of the software have. Okay, so we got client server roles, network machine boundaries, encrypted channels, authentication, and areas of responsibility within the system. Okay, so let's go over each of these. Okay, so first thing you should understand about security is how a computer network works. Okay, so a network is a collection of computers connected by a transmission medium. when you connect or write software for the web, it will end up being hosted on a web server. And clients may connect to your server, web browsers, phones, and anything else capable of sending network requests. Okay, so as you can see in the diagram here, this is the network. Okay, and it has to do with security in the regards that because many devices are connected, this leaves kind of backdoors and tunnels open for hackers and other bad actors to take advantage of. Okay, so whenever we're working in a channel within a network, we want to encrypt that channel. Okay, and so the reason why is anyone in the same network can view all the traffic we're sending and receiving. So in order to have a private conversation, we have to make sure it's encrypted by using a TLS certificate and redirecting our web traffic from HTTP to HTTPS. Okay, and you're going to see this S stand for secure. Okay, so here's a couple providers for TLS certificates. Symantec is probably one of the biggest, and then Comodo is definitely another big one. Of course, there's more than these two, but right off the bat, these are kind of the big players. All right, so next, let's talk about securing API endpoints. Okay, so because endpoints are generally publicly exposed, it's a good idea to set up some additional logic to verify the incoming API requests. Okay, so for example, if we go to github.com, we are going to start off as a guest, right? So anything we try to do as a guest, we can maybe view public resources, right? We can view other people's repositories, but we can't, create any or do anything else, right? And then once we sign up for an account, we're then an authenticated user, and then we can, hit endpoints and get access to our own resources. And then maybe if we have a role in some organization or something, right, we have even higher access for that. Okay, but you notice they don't just let guests have access to all these resources, right? They make sure that they set up roles, and that way you don't just have anyone available to anything. Okay, so another thing we can do as far as API security is incorporating rate limits. Okay, so imposing a rate limit for requests made to your API is a good way to ensure your site from getting attacked with several requests at once. So GitHub, again, is another great example of this, how do you say it, type of security in play. Okay, so if we open up our command line and we will go ahead and paste that request in, we can see that it sends it off, and right here, we notice we have a rate limit, right? And it started me off at 60. And after I made that request, you'll notice I only have 59 requests left, okay? And this prevents me from hitting their server with thousands of requests at once, which would bog it down and may crash it, right? So to prevent against this, we impose an API rate limit, okay? So, oh, wrong slide here. Back to web security. I don't know what happened there. Hold on, folks. Let's get back to our slide. Okay, so now that brings us to our DOS, or denial of service attack. Okay, so this is in reference to sending several requests to target machine or resource at once, and then preventing all of those or some of them from being refilled because we overload the system. Okay, so this is how we were demonstrating a minute ago how GitHub was only allowing us to make so many requests, right? Because otherwise anyone could just hit their endpoint with thousands of requests at once if they wanted, and ultimately attack and render their service unusable. So to prevent against this, we can use things such as throttling. Okay, so this is minimizing bandwidth being able to be used. Rate limiting, which we saw in action, right? This is giving minimum rate or maximum rates for requests made to an endpoint per hour, per day, whatever. And then web traffic monitoring is good. So, we can set up our APIs with logs and real-time, environments where we can be sent alerts in the event that we're all of a sudden seeing a huge spike over the course of a few minutes. Okay, next, let's talk about an XSS attack. Okay, so cross-site scripting is a type of computer security vulnerability typically found in web applications. XSS enables attackers to inject client-side scripts, typically through an input, into web pages viewed by other users. Okay, so how we can prevent against this is we can use something called sanitization. Okay, and sanitization is often available through lots of third-party libraries. So definitely, depending on the language you're using, that's going to differ, but the overall process is the same across the board. Next, let's talk about SQL injection. Okay, SQL injection is a technique used to attack data-driven applications, or applications with a database. So how it works is they take nefarious SQL statements and insert them into an entry field, and the point is, so it will dump the database contents back to the attacker. Okay, so because SQL statements are so close to plain English, they oftentimes can get past an input field, right? And then they can get executed in the server, and therefore, they're running queries on our database, which is not good. Okay, so to prevent against this, again, sanitization, right? To make sure that only raw text is being entered and not script or SQLs or anything to that nature. And then object relational mapping. This is another tool you can use to prevent against this as well. Next, let's talk about file uploads. And this one's surprising to a lot of people, but it's actually one of the bigger ones. Okay, so the way a file upload vulnerability works is the attacker uses something such as an executable file like a PHP, and then they call the corresponding URL from their web browser. And now they're running code on your server, which, as you know, is not good. Okay, so how we can prevent against this is something called a file type detector. Okay, so it only lets certain files be uploaded, such as JPEGs or PNGs, right? Something that's actually an image or the document file we want, but not, just any file out of the blue. Okay, so next, let's talk about ARP spoofing. Okay, so ARP spoofing is the technique by which the attacker sends a spoofed address resolution protocol onto a local area network. So the aim is to associate the attacker's MAC address with the IP address of another host, such as a default gateway, causing any traffic meant for that IP address to be sent to the attacker instead. Okay, so this is very much like intercepting a football, right? So the football is the request is being sent from one machine network, to another, and then it gets intercepted. Okay, so to prevent against this, there is that TLS certificate again. Okay, so you're going to see this a lot in regards to security because it's very important to make it secure these days. Okay, so next, let's talk about DNS spoofing. Okay, so DNS spoofing is a form of computer security hacking in which corrupt domain name system data is introduced into the DNS resolver's cache, causing the name server to return an incorrect IP address. This results in the traffic being diverted to the attacker's computer or any other computer. Okay, so this is a lot less common because typically your DNS provider is going to have a lot of security measures in place to prevent against this. But at any rate, to be safe as possible, there once again is the TLS certificate. Okay, I'm redirecting traffic from HTTP to HTTPS. All right, moving forward. Next, let's talk about the oh-so-famous firewall, right? In FBI movies and all that, they always say, I'm trying to get past the firewall. And so what is a firewall? Okay, so a firewall is a network security system that monitors and controls the incoming and outgoing traffic based on predetermined security rules. Okay, so not all firewalls are the same. And so it's always a good idea to make sure that the machine running your server has one set up. Next, talk about having a plan B. Okay, so no system is ever 100% completely secure. So it's a good idea to back up your data and operating system in case of emergency so your service is not interrupted for your users or customers. As well, you should have an emergency checklist. So if you're on vacation or something, right, your team can still take the immediate action needed to resolve the issue. So planning, preparing for the worst, right? That's going to really go a long way. All right, now let's talk about organizational privileges. Okay, so as there's oftentimes a large number of hands involved with the building of a single software project, it's a good idea to restrict access to things on an as-needed basis. For instance, a developer may have access to modify the code, but not to touch the production servers. And the operations team may have access to modify the server environments, but not the code. Okay, so employees quit all the time, employees get fired, right? People have, bad endings at jobs. And so last thing you want to do is someone who, quits your job or is mad at you, goes and, just nukes your database or something to that regard. That's totally unreversible. Okay, so only give out privileges as needed in that aspect. All right, now let's talk about protecting passwords. Okay, so when encrypting passwords, we first add a salt. Okay, and this is one approach. There's many approaches to encrypting passwords, but this is one of the more tried and true methods. Okay, so salt is a long random sequence, and we add that to the password and we run a hash on it. Okay, so a hash algorithm is used to verify that block of content has not changed. So this does two things. First, it makes it nearly impossible for anyone to guess the password without knowing the salt. Second, even if the attacker gains access to the salt, they won't be able to use the pre-computed hash tables to get the passwords out. They'll have to compute the entire space from scratch. Okay, so we won't say it's uncrackable, but it's used by, some of the bigger, more proven companies out there. And so definitely has a lot of validation behind it. So as well as encrypting your password, it's also a good idea to enforce it with some sort of password strength rule. We've all seen these, right? You must have a minimum of 6 characters, or you must have a special character. And sometimes, it might feel a little annoying, but at the end of the day, the main purpose of this is to prevent easy guessing. Okay, and so they never want, systems to be easily breached. And so if they let you pick the password or 1, 2, 3, right? Things like that are just going to be really easy to brute force and get through. So now let's talk about a higher level of security called two-factor authentication. Okay, so just a single email password, right? That's one factor, but two-factor authentication is when they have another device involved. Okay, such as like a phone. So I'm sure you've been through services where they've asked you to verify verify a code that was sent to your phone. Okay, and so you not only had to do the regular authentication part on your machine, your laptop, but you also had to do it through your device. Okay, and this increases the difficulty for an attacker because they'd have to compromise more than one device in order to successfully impersonate a specific user. So that's oftentimes really rare versus just losing your phone or just losing your laptop. That's not so rare, right? So that's why for certain specific applications, maybe financial data, stuff like that, you'll want something like two-factor authentication just as an extra layer. All right, now let's go ahead and take a look at some security resources. Okay, so of course you can always Google things. Never any harm in that. But then there are some official resources we recommend you check out to definitely keep yourself up to date and current. So first one is CVE. Okay, and this is a government database full of incidences reported, and so you can come here and you can check them out and keep up with all the news on how to prevent that. OWASP is another one. I like this one a lot because it's very much like a Wikipedia for for events and you know, such instances for security breaches. So I oftentimes come here, you know, if I need to know something. And then Verus is another you know, database. It's public, so it's got a lot of shared incidences in here, and definitely a lot of data to comb through and you know, learn from, so you don't have the nasty incidences happen to you. Okay, so let's go ahead and let's open up the floor, and let's see if anyone has any questions at this time. Okay, so the floor is open. You are free to ask away. Any questions today? Okay, all right. If there's no questions, thanks everyone for coming. Have a great day, and